So hi everyone, my name is Krista West and I appreciate the opportunity to meet you all and talk with you about the work I love to do. So as Tom mentioned, I am a Department of Geography student with both San Diego State University and the University of California, Santa Barbara, and that's part of the joint doctoral program. Today, I'm going to be talking with you all about wildfires, and I'm going to share how I use images captured by satellites to look at them. So I'm currently located over here in San Diego, and one awesome thing that I love about being a geographer and working with geospatial technologies is I get to look at maps and gorgeous images of the planet every day. So here's a picture of me on the left, circled in red at a young age, learning about firefighters and what they do. And my interest in learning about wildland fire has only grown since then. My goal is to work on projects that will help keep firefighters safe because they sacrifice so much to protect the communities that they serve. And watching the news, as I'm sure you've all seen, there have been a number of extremely large wildland fires. We had our first mega fire in California this year, and fire season is far from being over. So while fires are natural for the environment and necessary to help some plant seeds sprout and clear the land of extra brush every so often, they're still pretty terrifying for the people that they affect. So that's why I want to do what I can to help everyone learn about fires and better prepare for them. So you're probably wondering, what do I do? This is GIS Day, it's Geography Awareness Week. Well, I'm a remote sensing scientist, and it sounds fancy, but all it really means is that I can study things in one place from another place. Technically, as long as I'm not touching the object, that's remote sensing. So my job is to use data acquired over another place and learn more about it, and then share that information with you. All kinds of tools can be used to do remote sensing. Drones, airplanes, boats, submarines, even handheld devices. I use satellite imagery while sitting safely at my computer at home. That's remote sensing. And it can be used for so many different projects. I'm looking at fire-prone landscapes, but other remote sensing scientists might be looking at coral reefs, plants, cities, even other planets. Remote sensing is both science and art. It definitely involves STEM topics, but I also get to work with color combinations to better highlight what I want to see in the environment, and that's the art part that I love so much. And I'll get into that a little bit later in my presentation. So for the majority of my work, I use imagery taken by satellites out in space. Every day, all the time, we have these wonderful satellites traveling around our planet, and they're collecting all types of data for scientists. Some satellites have special cameras called sensors, and I use the pictures from those sensors. What I love about these camera sensors is that they can see beyond what you and I can see with our own eyes. So let me explain. Our eyes have two types of color receptors, rods and cones. So the rods, not to scale and not totally accurate, but you know that, allow us to see brightness and shades of gray. So for example, the rods in our eyes are what help us see better at night. The cones in our eyes are what help us see color in the daytime. And each of our three types of cones help us see red, green, and blue light. And the mixture of those three colors is what we call visible light. So as an example, here is what you or I might see when we look at the ocean. And just for fun, in case you're curious, here's what your pet dog or cat might see when they look at that same beach. They have more rods and fewer cones, so they can't see color as well as we do. But don't worry, they can see really well at night and have a great sense of smell too, so it totally makes up for it. So, okay, back to the fancy camera sensors I use. These sensors can see other types of light and energy within the electromagnetic spectrum. The electromagnetic spectrum is why we know there's more to a picture than meets the eye. So how does this even work? The sun produces a continuous spectrum of energy from teeny tiny gamma rays all the way to very large radio waves. We see visible light, but the sun sends us all of these other waves that we can't see with our own eyes. They hit the ground, some are absorbed, others transmitted, and others are reflected. And so everything on the ground has its own unique spectral signature. That reflected energy and those spectral signatures get captured by the camera sensor as it moves overhead. So here's the electromagnetic spectrum drawn out. Our eyes can see visible light, this tiny portion of the full spectrum. So for my work, I like to focus on the visible part of the spectrum circled in blue, but also I like to look over here circled in green, which is the infrared part of the electromagnetic spectrum. One way to think of the electromagnetic spectrum is like a piano keyboard. So we have all these keys, and I pick 3 keys to play at once, and we hear a sound. But with the work that I do, instead of playing piano keys and hearing a sound, I select color bands, and we see a brand new color combination in our picture. If we want to look at a picture the way we'd see it with our eyes, as if we're flying over Earth, we would pick red, green, and blue. So we can use those 3 colors to see what we call a true color image. So here's what one spot on Earth looks like if you see it from space. So we can see the brown mountains over here on the right and in the top. We can see the agricultural areas where we see those linear patterns. It kind of looks like a quilt. And down here, that blue-gray, that's city. So what if we adjust the color combination? Pretty cool, right? So in this scene, I'm using an infrared band, the red band, and the green band. So it's not immediately intuitive, but the more you work with it, the more you learn how to interpret these scenes. So this bright red vegetation, well, that's vegetation, and it's very healthy. This darker red is still healthy vegetation, but it's a different type of vegetation, probably something like chaparral or some sort of shrub. Over here on the left-hand side, you see those really bright red circles, and those are probably irrigated agricultural plots. And so that's pretty interesting that just by adjusting our bands, we can look at the scene in a totally different way. And here's one more example where with this color combination, it's a different infrared band, but still red and green. Healthy vegetation looks really green, but this magenta, purple, pinkish blob in the middle, that's what we call a burn scar. And so the more I work with arranging those color bands, the more I learn about different ways to look at our planet. And if you've ever used any of the fun filters, like on Instagram or on your camera, on your phone, different ways to change colors, it's kind of like that, to be honest. So now I would like to share some of the wildfire imagery I keep telling you about. When a satellite camera takes pictures of the Earth, it takes a whole bunch. And remote sensing scientists put those pictures together like you would do with a jigsaw puzzle. And when you see gaps in the pictures, like you do over here on the left-hand side or the right-hand side, that's just indicating that the satellite sensor didn't fly over that part of the planet that day. So this particular image was taken by what's called a planet scope sensor, and it was acquired over Southern California in December of 2017. You can see the ocean here in the bottom left. We've got Santa Barbara right here, Carpinteria, Ventura, and then everything above it is the land. And so what I can do now is look at a bunch of images taken each day. And if you can see down here on the bottom, there's sort of like a turquoise highlight as it goes through the days in December. So I'm looking at the fire progression of what was called the Thomas Fire. And that was ignited on December 4th, 2017, and was contained right around January 12th, 2018. But I can learn a lot more about the fire, where it's going, and possibly make predictions about where it's going next using progression images like this. So next, I'd like to show you a video captured by the Colorado Division of Fire Prevention and Control's multi-mission aircraft over the same fire. So this is still the Thomas Fire. And instead of a satellite, This is acquired from an airplane that has special permissions to fly over wildfires. Do you remember when I mentioned the infrared part of the spectrum? When the video switches to black and white, let me see if I can get it to play again. When it switches to black and white, right here, that's showing you the infrared part of the spectrum. So those white spots are representing a very hot part of the ground. That's where the fire is. And the darker it is, the cooler it is. So now I would also like to show you some pictures from the Sentinel-2 satellite sensor. And I am working on these pictures with a specific goal in mind. And today I would like to work with you to choose different color bands so that I learn a little bit more about my scene and specifically learn where the fire is. So this is visible imagery. Remember what you would see with your own eyes using the red, green, and blue bands. And let's focus on one spot that I've outlined here in orange and zoom in. So what do we see? More smoke, right? We can see maybe kind of like a greenish brown area up top. We see the smoke here, maybe some brown mountains down here. Does it tell us where the fire is? I mean, yes, because we see the smoke, but I think that we can do better. So what if we adjust the colors and bring in one of those infrared bands? Now healthy vegetation looks bright red. We can see a burn scar and we still see the smoke. So let's zoom in on that same exact location. What do you think? I mean, it's a useful band combination if we want to know where vegetation is. So remember with this band combo, healthy vegetation comes out looking really red. We see that the burn scar is down here. It's a little bit more clear than it was in the visible image. We see the smoke, we see some hot spots, but I have a feeling we can still do a little bit better. So what about this? Pretty promising, right? Let's zoom in again. Same exact location we've been looking at with the past two images. And this is still pretty darn good. We see healthy vegetation as bright green. We can see the burn scar as sort of this brownish orange, and we see those active fire fronts along here with those really bright pixels. Spoiler alert, let's just do one more and it will be better. So now I'm looking at just 3 infrared bands in my combination. Again, same exact area. I'd like to bring your attention back to that same spot and zoom in. So now we see that the healthy vegetation is blue in the top right. That brown scar is kind of a golden greenish color, but those active fire spots are much brighter and we can kind of see through the smoke. There's still some blurring where the smoke was before, but it's significantly better. So here are all of those close-up images layered on top, and I'll just move through them. And these are all acquired by one single sensor at the same time. So it's not multiple images, it's just a single image with multiple bands. I hope I've convinced you just how cool this is. I think it's cool. I bet you all think so too. If you're here celebrating Geography Awareness Week, I think you're liking it. So one advantage of remote sensing of wildfires is that we can look at that data from a safe distance. And then share that location information with firefighters. So a lot of times we can adjust the band so that we can see pretty well through smoke. And I mean, this is pretty hilly terrain. There's a lot of trees or a lot of shrubs in the area, so it's probably pretty hard to get to for somebody on foot. And we now have the ability to share with the firefighter the exact location of where that fire was. So my current research involves looking for areas with grasses that might be consumed by wildfires. So we have such a thing as the wildfire behavior triangle. So on one side, there's weather. Think about strong winds and low humidity, like Santa Ana winds, Sundowner winds, Diablo winds, depending on where you are in California. On the other side, we have topography. And our focus is mostly on really steep terrain because fire actually spreads faster moving uphill. And then the third side is fuels. So we're really focused on plants that catch on fire and spread that fire really easily. So eucalyptus, palm trees, grasses, especially really dry grasses, catch and spread fire very quickly. And so when we have variations in weather, because sometimes we really don't know what those extreme wind events are going to do, and variations in the fuels that we have, how dry or how moist it is, depending on whether it's been a drought year or whether we've been inundated with rain, that's going to make a big difference on whether the fire will stay small, burn slowly, or if it's going to burn really hot, get really big, and move quickly. So for my research, I am focusing on currently 2 small study areas in San Diego County, Mission Trails Regional Park, which is shown here, and then also Otay down south a bit. But eventually I will expand it all to about 7 counties in shrubland ecoregions in Southern California. I'm using Landsat 8 satellite data, so that's another satellite option that I have. And I'm looking specifically for grasses that are taking over and growing in new parts of the wild landscape. So my goal is to figure out how much of the area is covered by grasses so I can pinpoint places that are at risk of wildfires and then share that data with the firefighters. Depending on how healthy and green or dry and brown the plants are, I'm hoping to project or predict where an area might be more likely to burn if there is in fact a wildfire ignition. So we're looking at another infrared picture over here on the right-hand side. And you can see that super healthy vegetation is bright red, so that's a golf course. We've still got a lot of healthy vegetation here in Mission Trails Regional Park, but there's a lot of coastal sage scrub, chaparral, there's some grasses as well. And so I'm looking at better identifying what's what, where it is, and exactly how much there is. So I end up looking at a lot of images like this, where I'm trying to determine, is there a lot of grass in one spot? Is it possibly, 100% grass cover? And so that's what these red pixels are. The darker red it gets, the more grass is located in that area and, could be of greater concern for firefighters if we have a fire event. So I wanted to provide just a couple of resources, whether you're an educator of any grade, or if you're just curious to look at some pretty images, I think these are great. I get a lot of inspiration from them, and feel free to check these out. I mean, this is being recorded, so no need to write it down right away. But these are just a couple options that you can look at, you can share with your kids, with your students, whatever. And since I think I still have a little bit of time, I'd like to take a moment to just remind you that wildfire preparation is super important. Work with your families to check preparedness websites. This is CAL FIRE's website, which is really excellent. And make sure you're following advice from local firefighters and police so that you know exactly what to do in the event of emergency. And yeah, I'd love to talk with you about remote sensing wildfires all day. I will stop here because I'm probably approaching my time limit, or maybe I just talk so fast because I'm so excited that it's only been a few minutes. But I would love to take some of your questions, and the questions, they're never too basic, or we can try and go really high level and I'll do my best to answer them. Or if you're just curious about, how I got involved in geography, happy to answer that as well, because I love talking with people about it. So huge thank you to Tom for inviting me to join you all. And yeah, thank you so much.